Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is minimum operations to make array elements 0. In this problem, we are given a two-dimensional data which is called as queries. In this queries array, we are having multiple query, and each query is having two data. The first one is the left, the second one is the right. The first one is the left, the second one is the right, and we can have multiple queries. Now these queries are actually telling you that this is an array from 2 to 4. This is an array from 1 to 2. For example, if there is a query 3 comma 18, so 3 is L, which is left, 18 is right or R. So this 3 comma 18 is actually telling me that this query, or if this is the query 3 comma 18, then this is actually an array from 3 to 18. So 3 4 5 6 7 8 up to, it is going to up to 17 comma 18. It will go up to 18. So basically a query is actually representing a range of numbers as an array. So 2 comma 4 is actually equal to 2 comma 3 comma 4. Now our target here is to make each of the array in each of the query equal to 0. If you see in this particular example, we have two arrays, right? Or we have two queries. We have 1 comma 2 and we have 2 comma 4. 1 comma 2 means we have to start from 1 and go up to 2. That's our array. 2 comma 4 means we have to start from 2 and go till 4. Our goal is to convert each of these numbers to 0. It will be 0 comma 0 and 2 comma 3 comma 4 will be 0 comma 0 comma 0. That is our goal. Now to convert any number to 0, basically we are changing 1 to 0, we are changing this 2 to 0, we are changing this 2, 3, 4 to 0, 0, 0, right? To convert any number to 0, or basically if you want to reduce the value of a number to make it 0, we have to perform operations. And in one operation, basically we have just one type of operation, and in any one of the operation you perform, you just select any two integers from your array. Let us say those integers are a and b, and replace those a and b with floor of a divided by 4 and floor of b divided by 4. For example, if you have this array 1 comma 2, so let us select this 1 and 2. If I select 1 as my a, so a will be equal to 1, b will be equal to 2. Now you have to replace your two integers with a divided by 4 and take the floor of this. So a divided by 4 and b divided by 4. Basically we have to perform the same operation with both of the integers. So this will be equal to 0.25, this will be equal to 0.5, right? Now we have to take the floor value of this. So floor of this value is actually equal to 0, right? So we have converted our numbers to 0 in the first array. We have to do it for all the arrays or all the queries, whatever is given in the input as a query's two-dimensional data, right? Now we performed one operation to convert this particular first query to 0 comma 0. To convert the second query to 0 comma 0, you will have to perform two more operations. Basically right now our array is 2 comma 3 comma 4. We can select at max two numbers. We have to select exactly two numbers in one operation. So let us select 3 comma 4. So if a is equal to 3 and b is equal to 4, you divide this with 4, you divide this with 4, this will be equal to 0.75, this will be equal to 1.0. If you take the floor of the first number, this will be 0, floor of the second number will be equal to 1. So we have to replace this 3 with 0, this 4 with 1, right? So 3 will be 0, 4 will be 1, and we performed one operation. Now we can select 1 and 2, these two numbers in our remaining array, and just like we did for the first query, we are going to just divide 1 with 4, 2 with 4, and they will be converted to 0 in one more operation, right? So we performed a total of two operations to convert the second query to 0 comma 0 comma 0, and we performed a total of one operation to convert the first query to 0 comma 0. So total number of queries we took is 3, and that is the output, right? We just need to find out the minimum number of queries we need to perform to convert our numbers to 0. Now let me tell you a little bit maths here. The simple maths here is, if you want to convert any number to 0 following our operation, let us say the number is 16. If you want to convert this to 0, there is a simple formula. We can take log of 17, right? This is 17, we want to convert it to 0. When are we going to get a 17? Let us say we have a range, we have a query in which the range is L is equal to, let us say 10, and R is equal to 20. So our array is 10 comma 11 comma 12 up to 17 comma 18 comma 20, right? This is our array. When you have a query something like 10 comma 20, then this is the array, it will have a 17. You have to convert all the numbers to 0, right? So let us try to understand it from one of the numbers perspective, because we select one, not one but two integers in one operation, and we apply some formula on those integers separately. For a and b, the formulas are different. I mean, the formulas are same, but they are not related to each other. We replace a with floor of a divided by 4, we replace b with floor of b divided by 4. Basically we replace every number by dividing it with 4 and taking the floor of this, right? So every number, whenever you perform some operation and choose any two integers, these two integers are not related to each other. Any operation performed on those two integers are separate. So let us try to understand it from one of the integers perspective, that if you want to convert 17 to 0, there is a simple formula to find out how many operation it will take to convert this 17 to 0. Now the brute force way is simple, right? You can say 17 divided by 4, right? This will be equal to 4.25. Take the floor of this, this will be equal to 4. Now 4 divided by 4, this will be equal to 1.0. The floor is 1, right? So now you take this 1 divided by 4, it will be equal to 0.25. The floor is 0, finally converted to 0, and it took around 1, 2 and 3 operations. But we can directly just apply maths here. We can say log of 17 with the base of 4. This will be somewhere equal to 2.01 or 2 dot, I would say 02 something, but this will be somewhere 2 dot something, right? Now whatever is the value you are getting here, take the floor of this, take the floor value of this, that is, take the floor of your current number a, right? Not a, log of a comma 4, that is, take the log of a with base of 4, then take the floor value of this and say plus 1. This will tell me how many operations we need to perform. Log of 17 comma 4, basically this particular value is 2.02 something, right? To take the floor of this will be equal to 2, and take plus 1, this will be equal to 3. Exactly 3 number of operations we need to perform to convert 17 to 0 based on our current formula or current operation. Now what is the proof of this? See, the thing is, we have a simple proof. I will tell you. See, when we take the log of any number with any base, what we are trying to find out is, when we say log of 17 to the base of 4, we are trying to find out how much power should we raise this 4 to, that is 4 to the power what value will be equal to 17, right? How many times should I multiply this element 4 to make it 17? Now this is 2.02. It means you have to multiply the element 4 2.02 times to make it somewhere, equal to 17. That is 4 is to power 2.02 will be somewhere equal to 17. This may not be the exact value, but this is somewhere close, right? So this is what this particular formula is telling me. It means if you divide this element 17 with 4 and then again divide it with 4, because our value is 2.02, right? It means we have to take the power of 4 more than 2 times, right? But less than 3 times. But at least we have to take it 2 times, right? And that is why I'm taking the floor of this. I'm saying, okay, let me take the floor of this. I will divide it 2 times. Now when I divide it 2 times, I will get a value somewhere around 1.25. 17 divided by 4 will be, I think, 4.25. Then 4.25 divided by 4, I think this will be equal to 1.06, somewhere around this. Now again divide it by 4 and this will be equal to 0, right? Based on our formula, when you divide it, take the floor of this. And that is why I'm saying plus 1, because if you just take this particular value, right, this is just telling me that how much times you need to divide your element by 4 to make it around 1, in the range of 1. We have to convert it to 0 as well, right? So we are saying plus 1, right? This plus 1 is to ensure that when our number is converted to 1, somewhere near 1, that is less than 4, you again divide it with 4 to make it equal to 0. For example, if it is 16, we have to convert it to 4. Again, we have to perform 3 operations, right? Not 4, we have to convert it to 0, right? So we can say 16 divided by 4, then again divided by 4, then again divided by 4. This will be equal to 0. Basically, this is 4, then 4 divided by 4 is 1, then 1 divided by 4 will be 0, right? Now again, if you take the log of 16 with the base of 4, this will be nothing but 2, right? Now 2 plus 1 is 3. We have to perform 3 operations. So this is a simple formula to find out how many operations we need to perform on a number to make it equal to 0 based on our operation, based on what are the operation we can perform on a particular number. Now let us first try to solve this problem with total brute force. No logic, nothing, just a simple brute force, right? For that we can say, let us create a variable and let us name the variable as result, which is equal to 0. And now let us run a loop for L comma R in queries, right? Every data in the queries is an integer of 2 elements, right? Is an array of 2 elements. So they will be unpacked in the variable L and R. And now what we can do is, we can simply assign one more variable. Basically what we are going to do is, in brute force, we are going to create an array from L to R, and we are going to convert each of the element one by one to 0, right? And once we convert it to 0, we are going to count it at how many times we have, like how many operations we need to perform to convert it to 0. So we can say a temporary data is equal to 0. We are just going to count how many times we need to perform an operation from L to R to make it 0. So temp is equal to 0, and we are actually going to start from 1, right? Not 1, from L. So let me actually run a loop for I in range from L to R plus 1, because we have to run a loop from L to R to create an array from L to R. We could simply say that temp is equal to temp plus, we can say our formula is floor of my current value, that is the log of I comma 4. This is my current value, right? This I is actually representing my array from L to R, right? So take the log of I with the base of 4 and then take the floor value of this and say plus 1. Now these are the number of operations you need to perform. These totals are the number of operations you need to perform to convert a number to 0, right? Now I could simply say, after coming out of this loop, I could simply say result is equal to result plus temp, right? No, there is one more thing which you need to take care, which is, in one operation we can do the same thing on 2 different integers, right? So we could simply say that this temp means how many operations we need to perform to convert each number to 0. But since in one operation we can do it, we can do the same operation on two different integers, so we could simply say temp divided by 2. Why temp divided by 2? Because let us say there are 9 numbers. Let us say it is from 2 to 10. There are total 9 numbers, right? And it is telling me that we have to perform 20 operations to convert all these 9 numbers to 0. Now there are 9 numbers and we have to perform 20 operations. But in one operation we are going to do it on two different integers, right? So it means we have to just perform the operation 10 times to convert all the numbers to 0, right? So when it is 20, we have to perform the operation for 10 times. But when it is 21, we have to perform the operation for 11 times. 21 divided by 2, this will be equal to 10.5. We cannot perform 10.5 number of operations, right? We can either perform 10 operations or 11 operations. We have to perform 11 operations because we have to convert all numbers to 0, right? So we can take the ceiling of this. So I can simply say that whatever is my temp, just divide it by 2 and take the ceil value of this. And this is going to tell me how many operations we need to perform to convert all the numbers from L to R to 0. Now I could simply return the value of result and submit this. This is not going to pass all the test cases, but this is going to pass a large amount of test cases because this is the correct solution, but this is complete brute force. Here we are not using any kind of logic or something, right? But we are going to see a logic. First, let us see, are we getting time limit exceeded? Yes. We can see that 591 test cases have passed. So it looks like this is the correct solution, but it is not the optimized solution, right? Now let me tell you how to optimize this. Try to understand about this. See, the thing is, guys, what we are right now doing is, let us say we have a range from 1 to 16. It means our numbers are 1, 2, 3, 4, 5, 6, up to will be 14, then 15, then 16, right? Now, right now we are just running the loop and we are checking for all the 16 numbers that, okay, for 1, how many operation we need to perform? Okay, we need to perform 1 operation. For 2, we have to perform 1 operation. For 3, we have to perform 1 operation. For 4, we have to perform 2 operations. For 5, we have to perform 2 operations. And up to 15, we will have to perform 2 operations. And for 16, we have to perform 3 operations. And I will tell you why. Because see, the thing is, this is our formula, right? If I just copy this formula, you will see that this particular value is going to be 0, not 0, but this floor value, if you take the floor of this will be 0 till 3. This will be 1 from 4 to 15. Because if you say what is the log of 1 to the base of 4, this will be somewhere 0 point something, right? Now you take the floor of this will be 0. Similarly, for 2 it will be 0 point something, for 3 it will be 0 point something. For 4, log of 4 comma 4, that is log of 4 to the base of 4 will be 1, right? So before 4, all the numbers are going to be less than 1, the log of all those numbers with the base of 4. And if you take the base, not the base but the floor, then it will be 0. 0 plus 1 is equal to 1. So up to 3 we have to perform 1 operation, right? From 4 to 15 we have to perform 2 operations because now this value is going to be 1 point something. For 16, this particular value is exactly going to be 2, right? Because log of 16 comma 4 is 2, floor of 2 is 2. But for 15, log of 15 comma 4 will be 1.9 something, right? So if you take the floor of this, it will be converted to 1. So 1 plus 1 is equal to 2. So that is why I am saying there is a range of values for which the number of operations are already known, right? So we do not need to perform this operation. We do not need to find the value of how many operations we need to perform on a particular data, particular integer. We can just do it for a particular range, right? And our range is going to be multiplied by 4 every times. For example, right now our range is, let us say it is from 1 to 3, right? Now our range starts from 4 and goes till 615. Next our range is going to start from 16 and it will go till 63, just before 64. And for all these numbers, the data, the number of operations is going to be, I think it is going to be 3, right? Alright, so let me keep it here. What we can actually do is, we can have a result variable, it is fine. For L comma R in queries is fine. But let us say we have a range. From start it is 1, end is 4, right? That is our first range. Actually it will be from 1 to 3 because our first range is 1 to 3, for which the answer is 1. But let us keep it like this. Let us keep it like as a 4 only, and I will tell you why. Because later on, if you multiply this 3 with 4, you will not get the value as, you will get the value as 12, right? But if you keep it as 4 and multiply 4 with 4 to get the next range, which is 16, every time you can say that our range will be end minus 1. 4 multiplied by 4 is 16, 16 minus 1 is 15. That's our previous range. Then 16 multiplied by 4 is 64, 64 minus 1 is 63, right? So that is why I'm taking it as 4. Now, we don't need this loop, because this loop is actually giving us time limit exceeded error, right? This is the reason we are getting this error. But what we can actually do is, we can say for t in the range of 1 comma 16. And what is this now? I will tell you what is this. See, the thing is, whatever is your number, we know that our number has a range. Our number will always be less than equal to 10 is to power 9. Now this 10 is to power 9 is somewhere less than 4 is to power 16, right? It is actually around 4 is to power 15 or less than that, right? It means for any number, whenever you take the log of this, for any number, your number of operation which you are actually performing to make it equal to 0, that is either one operation or two operation or three operation, that will not exceed the value 15, right? Because log of whatever number you take, log of 10 to the power 9 to the base of 4, this will be around 15 point something. So if you take the floor value of this, it will be 15, right? So that is why we are going to run a loop for d in the range of 1 to 16. This d is telling me how many operations we need to perform. It will be 1, then 2, then 3, then 4. And now what we can actually do is, we can just find the range of the numbers which needs one operation, the range of numbers which needs two operation, right? But the problem is our range is not starting from 1. Our actual range, which is given in the input, it can start from 2, it can start from 6, it can end at 6, it can end at 5. It is not important, it will end at 16 or 15 only, right? So we have a defined set of values from 1 to 3, then 4 to 15, for which we know that we are going to take two operations. But the problem is we have to find the actual range, right? Our actual range can be different. So what we can actually say is, let's create our actual range left and right. The value of left is going to be the maximum of L comma start. We start from 1, but maybe just because our query is starting from 2, 1 will not be included, right, in our actual array range. So we are going to say whatever the max value of start and L, that is going to be my left, and my right is going to be the minimum of R comma end minus 1. We are saying that end minus 1, it means, let us say the range is up to 3, right? When end is 4, the range is from 1 to 3, right? It means our number is going to end at 3. But if our query is 1 comma 2, something like in the example number 1, if the query is 1 comma 2, we are never going to calculate for 3, right? So that is why we are capping our value left and right. Now we could simply say that if right is more than equal to left, we are only going to perform an operation if this condition is true, and I will tell you why we are using this condition. But let me tell you what is the operation. The operation is temp, which is used to calculate how many operations we need to perform to convert L, like that is a particular number, from L to R to 0. Let me actually get rid of this, and let me clear this as well. Now this temp will be equal to temp plus, I think the formula is going to be right, is right minus left plus 1. Now this particular data is telling me how many numbers we have from right to left or from left to right. That is, if our first range is 1 comma 2 comma 3, for which the number of operation is 1 comma 1 comma 1, then this is our range, right? It has three elements. Our start is 1, our end is 4, or we can say our left is 1, our right is 3, right? If you see here, our left is going to be 1, our right is going to be 3, right? So if you want to find out how many numbers do we have in that range, we can simply say 3 minus 1 plus 1, left minus right plus 1. For example, if our range is from 4 to 15, for which the number of operation we need to perform is 2, so we can say 15 minus 4 plus 1, right minus left plus 1, that will be equal to, I think it will be equal to 12, right? 16 minus 4 is 12, right? So this particular range has total 12 numbers. All these 12 numbers need two operations, right? So this is what we are trying to calculate, that how many numbers do we have. We have these many numbers, and all these numbers are going to take d number of operations, right? First the value of d is 1. Now next the value of d is going to be 2, right? So we have to update our start and end range as well. So we could simply say start is equal to start multiplied by 4, end is equal to end multiplied by 4, and this is going to be the new range, and we are going to do the calculation again. And why are we having this condition? Because our right value is never going to be more than R, right? Because we are taking the minimum of this. But our left value could be more, because it could be the maximum of start and L, right? Start keeps continuing. Start value variable will always going to be increased, right? We are going to increase our start value and end value, right? But since the left is the maximum of L and start, the left will be assigned as start, which is the huge value. So left will be more than right. That is not a valid range, right? We don't know our actual valid range up to what point we need to go. But what we are actually trying to do is, we are trying to say that, let me try to find out all the data for from 1 to 10 is to power 9, right? Not exactly 10 is to power 9, I could say 4 is to power 15, right? 4 is to power 15 is the range of numbers we are trying to find out the number of operations for. It will start from 1 to 3, which is going to take one operation, and then it will be 4 to 15, it is going to take two operations, then 16 to 63, it is going to take three operations. We are going to calculate for all the range, but we are only going to add it in our answer, because we are calculating it from 1 to 15, but we are going to add it in our answer only when this particular range, our L and R, is within this range, right? So left and right, so right should always be more than left, then only we are going to add the operations, and I think this should be good. Now what we can do is, we can, I think the temp, we don't need to calculate the temp again here, right? And I think this should be good now, right? Okay, let me just analyze the solution. It looks good as of now. and I think this should be good as well, right? Let me actually try to submit this. This should be good, but if we face some error, I am going to resolve it. All right, it is accepted, guys. So this is the perfect solution for this particular problem. Let me zoom out a bit and let me show you the solution. This is the complete solution for this particular problem, and this is a very simple problem. I would say not a too hard problem compared to if we are saying that it is hard. So I would say not. It is not hard. It is more towards medium, or you can say it is simple, because the brute force approach was very simple. Now to optimize it, you just have to understand a little bit of maths, and you will be able to optimize it, right? So I think, guys, that's it for this video. We have solved this particular problem, and if this video has helped you to understand the problem, the solution approach, and the, I would say, the intent, the intuition behind the solution, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.